last week. Okay, and then it's going to cover PVA, which stands for position, velocity, and acceleration. So remember, if you have acceleration, how do you get to velocity? Antiderivative, right? And then how do you get from velocity to position? Remember, you'll have a plus C, you'll have to find it, and then you're just doing sign charts, which you already should know how to do. Good? Yeah. Okay, quiz number 2 is over the stuff that we just learned and the stuff that we're going to learn today and Thursday. So it's going to be over geometric integrals, which is just like where you're finding the areas and stuff like that, easy. Okay, and Riemann sums, which is what you're learning today. That one will be on Friday.
Is it also partner?
It is partner. I'll let both of them be a partner, but Friday, second and third period, y'all have an assembly. So if you want the option to take it home over the weekend, I'm letting my second and third take it home because I'm not going to have class time with them since y'all have that senior assembly. So if you wanted to take it home for homework, fine, but you have to do it over the weekend, and that sucks. So I'd say just do it in class. But if you don't finish for whatever reason, then you can take it home. Good?
What does that say? What?
Riemann sums, that's what we're learning today. So if you want to title your one page of notes, okay, it is either pronounced Riemann sums or Riemann sums. People say both. Doesn't matter. I have always said Riemann, but I've heard it called Riemann, and that's not necessarily wrong. Okay, so a Riemann sum, okay, RS is used to approximate integrals of non-geometric functions. Okay? So here's what that means. If it was a geometric function, you just pick what shape it is, use the formula, blah, 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 like we've already been doing. Okay, but if it's not a geometric shape for the graph, then you need a different method. Okay, so draw for me, please. Okay, we're going to do a function f of x, but it can't be a straight line or it's going to make like a triangle or a trapezoid. So I want you to do kind of like a wiggly line like that. Okay, you can make it go all the way through if you want. But we're going to find first the integral from a to b of f of x dx. Now we'll say a is here, b is here. How do I find the integral from a to b? What would I need to compute? The area. Okay, so what's the problem though? That's not a rectangle, not a triangle, it's not a semicircle. Okay, so we're out of luck there. That's the exact area under the curve on the interval a to b. Yes. What's wrong with it? Let me see it.
Literally wasn't right.
Curve under the curve on a to b. Okay? So the first Riemann sum that we're going to do is going to be a left Riemann sum. So put left Riemann sum. Here's how it looks. You are going to take a to b, the subinterval. Okay, do this step by step so that you don't get lost. You're going to cut it in half. Then you're going to cut each of those halves in half. So ready? This half, cut it in half. This half, cut it in half. Now how many pieces do you have? 4. Easy, right? Okay, what I want you to do next is I want you to draw little dotted lines where you sliced it. So the first thing that you do is you're going to take a to b and you're going to cut it up into 4 pieces. Then from there, you are going to construct rectangles using the left y value of the subinterval. This is what I mean by that. This is column 1. We're going to call it A1 for area 1. I'm going to do the width here, which I'm going to call delta x, times the height of the left y value. I'm going to call that y1. So let's write down here. My left Riemann sum would be delta x times y1. Now, why am I doing base times height? Because what shape did I just make if I multiply delta x times y1? A rectangle, and that's how you find the area of a rectangle. Okay, next one. Going to do it in green. This is going to be A2. This is my second rectangle. I'm going to use y2's height to construct a rectangle, and then I'm going to find the area of that rectangle doing base times height. How wide is the base, we said? Delta x. And then how tall is it? Y2. Okay, now we're going to do a third rectangle. We'll do this one in purple. Okay, y3 is right here. I'm going to use the height of y3 to create a third rectangle. Then I'm going to compute its area doing base times height. The width of the base is delta x. And then y3 is the height of the third rectangle. Now, I have one more rectangle. Okay, and for my last rectangle, okay, I'm going to use y4. I'm going to cut across. There's my fourth rectangle. And then to find the area, I would do delta x times y4. Now, is there a fifth y value up there? Does it ever get used? No. Okay, there is a fifth y value for b, okay, but I never used it because it was never the left side of a subinterval. Make sense? Okay, redraw, exact same picture, but now we're going to do a right Riemann sum. So, squiggly line going up, A to B is going to be here. Here's my exact area that I'm trying to calculate. Okay, but it's not a geometric shape, so I'm going to do a Riemann sum. I'm going to cut the interval in half. Then I'm going to cut each of those intervals in half. And then I'm going to divide up my space into 4 chunks. So, line, 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 line. Now, for each of those rectangles, if it's a right Riemann sum, what do you guess is going to be different? Instead of using the y value on the left, I'm going to use the y value on the right. So let's go ahead and label them. This is y1, this is y2, this is y3, this is y4, this is y5. Okay, here's rectangle number 1. Am I using y1's height or y2's height? Which one is on the right? Y2. So cut across. That's your rectangle. Now let's find the area of that rectangle. How wide is it? Delta x. And then how tall is the triangle? Y2 plus. Next rectangle. Now I'm doing A2 here. Okay, A2 has 2 y values, y2 and y3, but which one am I going to use? Y3 is on the right, so y3 is the height that I'm going to choose right there. So that'd be delta x times y3 plus. Next one, y3 versus y4, I'm picking y4. So that'd be delta x times y4. And then for my last one, I'd use y5, delta x times y5. Now, which y value never got used in a right Riemann sum? y1 gets skipped. So if you want to make a little note here, y1 gets skipped. Okay, versus up here for my left Riemann sum, y5, or the last one, is skipped. Okay, now that we've already drawn the picture, I'm going to shade it in here, and let's talk about estimations. So remember, the rectangles are approximating the actual area. So look at picture number 1. How do my rectangles compare to the area? Are they exactly the right size, too big, or too small? Okay, this is an underestimation. The reason why is because each of these little chunks here are error that you missed. Make sense? Okay, now go down to the second picture. Second picture, are my rectangles exactly right, too big or too small? These are too big. I have a bunch of extra error. That makes it an overestimate or estimation. Make sense? Okay, there's one more type. It's called a midpoint. So when you're ready, I'm going to turn the page, draw the picture again. Am I good to turn it? Okay, here we go. Okay, last picture, exactly the same starting point. Okay, squiggly line kind of going up. A's here, B's here. Cut it in half, cut it in half. Don't draw your vertical lines though. Okay, just go to there. Here's my exact area that I care about. Okay, what I want you to do instead is, if you're going to do a midpoint, you have to leave a point in the middle. So rather than making my delta x cut it every time, I'm going to skip one. Here's why. What point am I going to use for the top of the rectangle? Not the left or the right, but the middle, because this is going to be I think I said it, but I forgot to write it, midpoint Riemann sum. So for a midpoint, you would say, okay, well, here's my middle x value. How tall is it at that point? And then draw your rectangle in like that. Okay, then for my next subinterval, I don't want the left or the right, I want the middle. So I'll find how tall it is at that point, and then form my rectangle like that. So, my delta x would be here. Notice it's a little bit wider. And then I would multiply by, if this is y1, this would be y2. Then I wouldn't use y3, but then I would use y4. So I'd have delta x times y2 plus delta x times y4. Now, one other thing to point out with you here for the estimation side of it. Okay, where is this chunk? Too much or not enough? Okay, my rectangle's too much, but then what's this? They kind of cancel out, right? Then over here I have a little bit too much, but then over here I have not enough, to where those errors typically kind of cancel each other out, making this the most accurate of the three. So I'm going to put here, error is both above and under, so they cancel out. Therefore, this is usually the most accurate. Okay? Also, can you tell if it's a little too big or a little too small? No. So you know it's going to be closer, but you don't know for sure if your answer is too big or too small. You just know in general that it's going to be closer. Okay, so now you know all three. Go to your little sheet. Okay, your classwork. Okay, we're going to do it together. It's not homework. You don't ever have to do it for homework. We're just going to do it right now. Okay, so take a look at your first question. Okay, it says, coal gas is produced at a gasworks. Pollutants in the gas are removed by scrubbers, which become less and less efficient as time goes on. R of T represents the rate scrubbers remove pollutants during production, measured in tons per month. The table of ROT, blah, 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 right here. Okay, so the first thing that I'm going to have you do is sketch a picture. So I'm going to say 0, 1, 2, 3, 4, 5, 6. 0, 22, we'll say is here. This is like an easy sketch. Don't count all the way up to 22. Okay, then 17 would be a little bit less. Then 13 would maybe be here. Then 10, then 7, then 5, then 2. So this is a graph of R of t. Okay, so first we're going to do a left Riemann sum. Now, when they give you a table, you have to cut your graph up in the pieces that they tell you. So they told me 0, 1, 2, 3, 4, 5, 6. Those are the pieces that I have. And first, I'm doing a left Riemann sum. So that means that for each of my areas, I'm going to pick the left side to make the triangle, or the rectangle. Okay, so look, watch. I'm going to go left side, cut across, and down. That's my first rectangle. Then I'm going to start at Y2, cut across, and down. Y3, cut across, and down. Y4, cut across, and down. Y5, across, down. Next one, across, down. What about this last little guy? He gets skipped. Okay, because remember, he's never the left side of a rectangle, so he doesn't count. Okay, now let's find the areas. Ready? So my first delta x, how wide is it from 0 to 1? 1 multiplied by, what is my y value on the left side?
22.
This would be 22. So 1 times 22 plus. Next subinterval, so I'm going to put a little check there. Okay, I did A1, now I'm on A2. How wide is it from 1 to 2? Still 1. And then what's the left y value? 17. So 1 times 17 plus. Okay, put a check. Next one, I'm doing the width from 2 to 3 is still 1, but my left side y value is 13. Okay, plus. Next one, what's my y value? 1 times 10. What's the next one? Next one. Is there a next one? No, 2 never gets used. Okay, then you would add all that crap up, blah, blah, blah. So this is delta x times the y value on the left. Okay, it's delta x times the y value on the left. Okay, now you would multiply it out, blah, 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 add it up, you're done. Okay, next question. Is your estimate over or under the actual value? Okay, well, if I connected these and I sketched the real area,
over.
this time it's over. Now, let's talk about last time a left was under. The reason why is because now my function sloped up. So it depends which way your function's going. Okay, so I would say for this one, this is an overestimate because R of t is decreasing. And now think about if R of t is decreasing, then what is the left y value? Too big or too small for all the other ones? It's too big. So, left side is always higher than other y values. Okay? So this one is an overestimate because since my function is curved down, my left side is always higher than all the other little pieces on that subinterval. Okay? All right, now for the right Riemann sum, okay, I'm going to re-sketch the picture. If you want to draw on your same picture, I don't care, but I think it might look confusing if you do that. So, right Riemann sum. Okay, we have 1, 2, 3, 4, 5, 6. Okay, split your graph up into pieces. So, whoosh, 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 whoosh. And now I'm using which side? Okay, a right side. So that means out of my first 2 points, I'm going to pick this one. Then out of the next 2 points, I'm going to pick this one. Then I'm going to pick this one, then this one, then this one, then this one. Now think about, if I add up all those rectangles, how is it going to come out compared to the actual area?
It's under.
Okay, this is going to be an underestimate. Now, on the AP test, you would kill tons of time redrawing the pictures every time. So it's a little bit easier, I think, to just use the table. So this is what you're going to do. Okay, you've drawn the picture, you get the idea. Okay, from 0 to 1, how wide is it?
1.
Okay, and then what's the right y value? Because 22 gets skipped. So 1 times 17 plus. Next one, from 1 to 2, what's my right y value? 13 comes next, plus. Next one, 2 to 3, my width is still 1, but now I'm using 10. Then 1 times 7, then 1 times 5, then 1 times 2. Who got skipped? 22 never got used because it was never a right side. Does that make sense? Okay, last one. Go down, kind of resketch your picture. Okay, for the last one, we're going to do a midpoint. 2, 3, 4, 5, 6. So 1, 2. Ooh, hold on, don't do that. What do we have to do when we're doing midpoint? Remember, you have to skip. So you're going to go from 0 to 2, skip 1. Then from 2 to 4, skip 3. Then from 4 to 6, skip 5. So this is 1, 2, 3, 4, 5, 6. Now, when I skip, how big is my delta x going to be? Now it's going to be double, which would be 2. And then when I use my y value from 0 to 2, I have to use the middle y value, which would have been the y value at 1. How tall is the y value at 1? Look at your chart. 17. Okay, now my next subinterval is from 2 to 4. Whose y value am I going to use?
13.
3's, which is
10.
10, because you have to skip, remember? And then from 4 to 6, whose y value am I going to use? 5's y value, which is 5. And then when I set up my area, it's going to be delta x times y, delta x times y, delta x times y. Your first delta x is a width of 2, thank you. And your y value was 17. You did that one. Plus, your second y value was still a width of 2, but now it's multiplied by 10. Bless you. And then your last one is a delta x of 2, but a y value of 5. Does that make sense? Okay, they can't do that. So if it was an odd number of intervals, they'd either have to give you another point, or they'd have to pick left or right, not middle. Okay? Now, what did we say about over, under? Can I do it? Okay, NA. We don't know. Now, you could say it's more accurate, but you don't know if it's too big or too small. Good. Okay, turn the page. Now we're going to look at one where the subintervals are not always the same width. Okay? So, turn the page. It's not really that much harder. It's mostly the same. Okay, turn the page. Last time we knew 0, 1, 2, 3, 4, 5, 6. Now we don't know equal points each time. So, what are my points given to me? I know 0. I know 30. Okay. I know 40. I know 50. And then 90. So I have to split up based on what's in my chart. So if I don't have the numbers in even numbers, then I have to go with whatever they give me. Now, the first one that they asked me to do is a left Riemann sum. So let's do a left side. So from 0 to 30, which y value am I going to pick? 20. Cut it across, do your area. What is my delta x? How wide is it? 30 times, what's the left y value we said? 20 plus. Next one.
30.
Okay, I'm using a height. Now, be very careful about how tall is it according to the table. It looks like it's 30, but really it's 32. So, I'm going to use a width of how far? 10, and a height of 32. So, 10 is the width, 32 is the y value. Make sense? Okay, my next one. Okay, it's 10 times 41. How did we get 41 instead of 40? Because we're looking at the chart. So it'd be 10 times 41. Okay, next one. We're going from 50 to 70. How wide is that? Okay, that's a width of 20 and a height of what? 55. Oops. Okay, and then for my last one, how wide is it? 20. And then my height is 65. Very good. Okay, now look at your error. Where your rectangles at, are they too big or too small? Too small. So that would be an underestimate because, and then remember you have to say two things. You have to tell me which way the function's going and then which side you used. So I would say because r of t is increasing, so the left y value is greater than other y values. Something like that. Okay? I use the left, actually I didn't mean to say greater than, what should I have said? Less than, fix that. Okay, so if my function's going up, then the left side is going to be the smallest on each of my subintervals. That makes my estimation come out under. Okay? Alright, let's do the next one. We'll come back and do the meanings probably tomorrow. Okay, so look at the next one. I want to write Riemann sum. Now, I'm not even going to draw the picture this time. Let's see if we can do it without. Because drawing the picture takes a bunch of time. It's a time test, blah, blah, blah. Okay, so look at your first one. I want to write Riemann sum. So, from 0 to 1, what's my delta x? 1. And then which of these y values is the right side? 45. Plus. Next one, from 1 to 3, what's my delta x? Okay, my delta x is 2. And then what is his right y value? 16 plus. Next one, from 3 to 6, what's my delta x? 3. What's my right y value? 10. And you can kind of circle them as you go. Okay, from 6 to 7, how wide is it? 1. And then what's my right side y value? 2. Next one, from 7 to 8.2, what's my distance? 1.2 on the x-axis multiplied by a y value of 1. Okay, now, real quick sketch here. My y values were getting smaller, yeah? So, if my y values were getting smaller, and I did a right side estimation, it will be an underestimation. Now notice, I didn't do an exact graph like this. I just made sure it's going the right way. Either it's increasing or it's decreasing. Those are your two choices. So I did a decreasing graph with a right side Riemann sum.
So it could be even more.
Oh, you're right. I didn't do, hold on, then we messed up somewhere. We did 40, oh yeah, I didn't do the last one. Thank you. From 8.2 to 9, how far is that? 0.8, and then my right y value is 0. And remember, for a right side, which one are you skipping? The first one, okay? Now, for a midpoint, okay, you're going to have to change the game. You have to skip one. So I'm going to do this one in pink. I have to go from 0 to 3. What's my delta x? What's my center y value? 45 plus. From 3, I have to skip 6. Where am I landing? 3 to 7. That's a distance of how far? 4, what's my center y value at 6? 10. Plus, last one, from 7 to 9. 2 is my width, what's my center y value? 1. Does that make sense? Okay, then can you answer over or under for a midpoint? No. Okay, NA. Can't do it for that type. Okay. Alright, turn the page. Did y'all get that? Sorry, did I go too fast? Okay. We'll just do 4, and then we won't do we probably need to do 5, I guess. Okay, you're going to Gilligan's Island. Woo, there's your velocity. Okay, we're skipping the interpret for right now. Use the table to find the integral from 7.5 to 9.5. Now, 7.5 is 7.5, that's 730. Okay, and then 930 would be 9.5. So are we good with, they're telling us to integrate the table? Yeah? Okay, then it says using a midpoint estimation and 30-minute subintervals. Now, they're telling you 30 minutes. Is that going to make you skip one anyway? Yeah, so they're trying to help you out, right? So here's 30 minutes. Here's 30 minutes. Here's 30 minutes. Here's 30 minutes. Then I'm going to circle all of the y values that I'm going to use. So from 7:30 to 8, what's in the middle of that? 7:45, what's the y value? 25. From 8 to 8:30, what's the center time? 8:15, y value is 22. From 8:30 to 9, it's 8:45, center y value is 10. And then from 9 to 9:30, center y value is 26. So when I do my midpoint sum, remember that it's delta x times y. Delta x times y plus ... What will my delta x be if my table is in miles per hour? 0.5. Because how much is 30 minutes, but I'm counting in hours? Half. So it would be a half times 25 plus a half times 22 plus a half times 10 plus a half times 26. Make sense? Now, I want to point something out to you, that if I have every single term with a half on it, could I GCF that half out to the front? Okay, so the short version of that would be for you to take the 1/2 out and then just add 25, 22, 10, and 26. But question, can you do that if delta x isn't always the same? No. That's only an option if your delta x is the same every single time. Make sense? Okay. You do not have to multiply these out. I'm assuming you can type it into the calculator. If on the AP test it's multiple choice, punch it in, get your answer. But if it's free response, you would leave it like that and you'd be done. Okay? So take a look at number 1 on your homework. Yeah. Okay, number 1, can I shortcut the table when I do my Riemann sum? Yes or no?
No.
Okay, no. Why not?
Different time.
Yeah, the delta x's are changing every time. So if I'm doing a right Riemann sum, okay, remember, please don't draw the pictures. It'll take you like 100 years. Okay, from 0 to 1.5, how wide is that? 1.5, and then I want a right Riemann sum. Which y value do I pick? 180. Plus, bless you. From 1.5 to 2, how wide is it? 0.5. What's my right y value? But I'm not touching 360. I'm going from 1.5 to 2. 241. Okay, next one from 2 to 4. What's my width? What's my right side? Okay, plus 4 to 6.5. Okay, 2.5. Right side is 480. Okay, plus 6.5 to 7. How far? 0.5. Right side is 500. Plus, picking up on the second row, Okay, 7 to 9 is a width of 2. Right side is 515. 9 to 9.4, how far is that? 0.4, what's my right side? 605. Then last one, 9.4 to 10. 0.6, right side is 650. Who got skipped? First side. Now, draw your little picture. Just sketch it though. Is it going up or down? Okay, it's going up. So I'm going to just do it right here. Whoop. Did I use the left or the right side? Okay, right side. So if I cut right side across, it's going to be an overestimation. Make sense? Okay, now we're going to do the same one but with a midpoint. Midpoint means I have to do what? Skip. So I'm going to go from 0 to 2. How wide is that? What's my center y value? 180. Okay, then from 2, where am I skipping to? 6.5. How far is that? 4.5 times the center y value is 360. Okay, then next one, 6.5 to 9. How far is that? 3.5 times center y value of, it is 2.5, thank you. And then your center y value is 500. Then from 9 to 10, how wide is it? 1, and your center y value is? 605. Huh?
2.5 and 515.
2.5.
Oh, no,
Oh, okay. Good? Alright, let's do one where you can do the little shortcut that I just showed you. So, turn the page, back side. Let's do... Okay, we can do 7. Yeah, still on the homework. Okay, so ticket taker at Six Flags wants to estimate the number of guests who went through the park on the given day. Okay, number of guests, blah, 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 there it is, from noon to 6 p.m. Use a right Riemann sum to estimate how many people came in the park. Now, what's your delta x every time?
1.
Delta x is 1, and it's 1 always. Then I can take 1 out and just add all of the right side y values. Who gets skipped? 9. So 9 is out, then I just do 12 plus 1 plus 14 plus 11 plus 7 plus 2. And you're done. And you don't have to keep writing the delta x every time. You can just add the y values plus ... Okay? But that's only when you have equal sub-intervals. Does that make sense? Okay, good. Okay, so I'm just going to help you set up number 8. This is just like the example we almost got to but didn't. How do you think that I would do an integral if they give me an equation? Put it in and get your own table. Now, you have to set up the table, so I'm going to type it in. So I'm going to do y equals x up to the 3 minus 3x. Oh no, I'm in the thingy. No, minus 3x squared plus 8. Okay, and then I want to go from 0 to 6. So 0, 1, 2, 3, 4, 5, 6. And then I would just write down each of my y values. Does that make sense? So I'd use 8, 6, 4, 8, 24, 50, 8, 116. And then what type did they tell you to do? Left Riemann sum. Now be careful here. They said with 3 subintervals. So if I want to divide 0 to 6 up into 3 pieces, how wide does each piece have to be?
2.
So 0 to 2. Where's my left side at? 8. Then 2 to 4. My left side would have been 4. Then 4 to 6. My left side would have been 24. If they had asked for a midpoint, I'd be using the center point. So this says that I need to do 3 chunks only.
Could you still just pull the 2 out?
Yes, my delta x is always 2, so I'm going to pull that out, and then I'm just going to add the y values. So it'd be 8 plus 4 plus 24. Make sense?
Yeah.
Okay, good job. Yes?
What does interpret the meaning of
We will do that tomorrow. We didn't do that today. Okay, you have like